Okay, we want to start. I'm happy to open the afternoon keynote session. We are going to have a very busy and exciting session. Our first keynote is Professor Gabby Sarusi from Ben-Gurion University. Professor Sarusi is a professor of the Electro-Optical Engineering Department at Ben-Gurion University and the chief scientist of TEXI, Augmented Vision Ltd. He holds PhD from Tel Aviv University in Physical Electronics. He did his postdoc at AT&T Bell Labs and NASA JPL. His main area of research are quantum structure photonic device, bandgap engineering, and augmented reality. Professor Sarusi will talk about the use of augmented reality, machine vision, and deep learning tools to enhance technical visual support device.
Thank you, Kobe, for the nice introduction, and thank you all for staying. It's just amazing to see the number of people that you managed to gather here. I believe that next year it's going to be 2 days conference, not only 1 day. This is the way to go. Anyhow, today I want to talk about the subject that is just projected over there, and it has the holy trinity of the three buzzwords, which is augmented reality, machine vision, and deep learning. We are very close to Passover now. In Passover we say Pesach Matzah Umaror in Hebrew, so you have the three buzzwords. Anyhow, what is the connection between those deep learning, augmented reality, and machine vision with technical support? So this is all about the TEXI, and basically the outline of my talk will be as follows. I will just give you a very short introduction of TEXI, short 2 slides of company overview, and then I will get to the what is technical visual support, and what is the opportunity, and what is the motivation for this. And then I will go to talk about customer service challenges, what is the role of visual support, what we call TEXI Live. This is the product that we already launched during 2017. And then we'll go deeper into what is the role of AI for the improvement of the customer support services, what we called TEXI Smart. I will talk about the roadmap and the approach that we have adopted. And then we'll go a little bit to a technological drill down. I will talk about how to minimize the network training cycle, how to artificial increase the training database using smart augmentation, the use of transfer learning to minimize the required training data, and also talk about segmentation. Who is TEXI? TEXI was founded in 2015 by 3 founders, Eitan Cohen, Amir Yoffe, and myself. We are located in Herzliya. We had a fundraising of $7.5 million. We have 3 workers, and we have a very solid basis of IP that we wrote. And we already in 2017, we have deployed what we call the TEXI Live, and we got sales of 1 digit in million. And we are ready for 2018. We already have a confirmed contract for a few digits. We have also a very good market traction. You can see here the amount of companies that we are involved with. And at the top bar, you can see the improvement that we give to our customer, which are technical support centers. For example, 20% increase in first call resolution. All of us are aware of the frustration that we have when we are on the phone with the technical support center, how frustrating it is. We got 17% reduction in technician dispatch, which is the most costly part. 40% increase in NPS customer experience, and a 12% decrease in average handling time, which is time is money in this case. So what is the role of a visual support system? What we call Taxi Life. This is already an ongoing product. The rationale behind it is by 2020, the number of things that will be connected are going to be something like 20 billion things. I just yesterday saw another survey by Ericsson saying that by 2022, there will be 29 billion. So this number are probably right because they are confirmed by two sources, two independent sources. And there is a challenge how to support. The devices are becoming more and more complicated. Not all the people are very good in technology. Many of them are technology challenged. And therefore, the demand for technical support services are going to increase furthermore. And what about the cost model? The cost model for support for delivery is very, very tough. The graph said the vertical axis is the cost, and the horizontal is the type of services. So people, when they want to install a new device or to support themselves, they can go to the YouTube and key how to, and then they can find, if they are lucky, a video that basically shows how to install something or to fix something. This is good for people who are very much into technology. It's very bad for people who are technology challenged. The other case is when you are calling by your phone to a technical support center, and then after you are waiting on the phone for about 30 minutes, you get an answer, and then you have the representative, the agent, that responds to you and guide you through the phone what to do after he questions you for about another 30 minutes. This is a completely time-demanding solution, and the most costly one, which is the most effective one as well, is technician dispatch, namely sending a technician. For the enterprises, it's the most costly solution. So all the enterprises don't want to get into this solution to a technician dispatch, and they try to avoid it as much as possible. There is also one big dissonance when you're on the phone with the agent. What the agent sees is what you see on the right-hand side, and what the customer sees in his home, in the office, is the very messy picture that you see on the left side. So there is a big dissonance between the two images, and what we try to do is to bridge this gap, namely the agent will see exactly what the customer or the client see in their home. And for this reason, we develop our Taxi Life, and basically the idea is to transfer the customer support inquiry into a visual technician visit. It's like to have a technician at your home. So the basic idea is that when you are calling the technical support center, they ask you whether you have a smartphone. If you have a smartphone, they send you a link via the SMS. It's not an application. We insist not to have an application because not all the people will upload application or download application. And therefore, we are doing all this service on the web. And basically, once you got the link, you press the link, and then you open the rear camera of the smartphone or of your iPad, and you start to have a video chat where you are basically videoing the device that need to be care of. You are getting the instructions, so up to now it's nothing new, it's very simple, you can do it with the Skype. But what's special about is that we implemented and we embedded in the Taxi different type of capabilities, such as augmentation of symbols, augmentation of annotations, augmentation of arrows, as you can see here. So basically, during the guidance of the agent, You have all this parameter in real time superimpose on your video. So even very, very technical challenging people can understand what to do. So it's quite obvious, it's quite self-explanatory. So this is what we have today, and based on this capability or this platform, we already have sales in 2017. We are going to have sales in 2018. But this is not this is not the final, because the ultimate goal, if you will ask all the directors of a technical support center, the ultimate goal is to get rid of the agents, namely to have a full virtual support, namely no person involved, no human in the loop. This is the ultimate goal of all the technical support center. By the way, it's the goal of the client themselves, because there was a survey that says that people prefer to talk to a virtual agent and not to a human agent. Most of the people, because it's very, very intuitive, it's very fast, and especially that you don't have to wait on the phone for a long time in order to get the next free agent. So the idea is to have what we call the visual assistance. In this case, there are some survey that says that if you are implementing AI, I'm sorry about the view graph, something happened when we transfer the slides. So there is a reduction in the service cost by 75%. There is enhancing of customer experience and the satisfaction by 85%, and of course 80% increase in agent productivity. So in Taxi Smart platform, we mimic what happened in the car industry, namely starting with a car that is driven by a human being, a real driver, and going all the roadmap toward the full autonomous car. This is the roadmap that we have adapted at Taxi, but instead of cars, we implemented on a technical support. So this is the basic idea, and the roadmap says that of course, today we start with a human agent, and then we are going to agent assistance. This is Taxi Live, and then agent advisor, namely the agent can get advice from the system once it recognizes the device, what are the usual fault of this device, and automatically provide solution, because it's already learned from previous cases what is the best solution to offer the customer. And later on, when the system will be trained enough, and then the system can be fully automated, namely the customer will call the technical support center, and then he will get a return call from a chatbot that basically will analyze the problem by analyzing the words, the voice, and will propose the solution, which is based on experience that you already learned from previous cases. So this is the way it's going to go. You connect the technical support center, it sees, and it guides, and eventually it's validated. But what we are doing today in Taxi Live that looks quite trivial, we are preparing ourselves for the Taxi Smart stage. What we are doing by actually storing all the videos and all the images, all the frame from such a chat, we are gathering all the images. We are creating a huge database. In Taxi Cloud today, we have 100,000 of images which are technically oriented, this kind of device, and you can imagine what you can do with such huge database. And once we have this database, and we will apply this database for future Taxi chatbots, it will be the basis of the deep learning that we are going to do in the near future in order to eventually become a chatbot. So in Taxi, we have a very large repository of images taking throughout all these video chats. And basically, we don't only have the image themselves, but we have the most common fault that each one of the instrument may have. Namely, if we have here, for example, a LG television, we know in LG television what is the most common problem that this device has. And so the agent can see it and get instruction by the system how to solve the problem. So it's basically a system that assists the assistants. And eventually, as I said, that once we will gather all these images, all these question and answers, all this solution, we will be able to move to a complete chatbot. In Taxi Smart, we will have a virtual agent. What is a virtual agent? Once it sees the device, it can basically analytically recognize the device and the type, the model, and display the contextual help, namely what is relevant for this device. In addition to that, we can also see, for example, error message on the device, and we already have stored what is the meaning of the error message, and give the answer and the instruction to the customer what to do with this error message. And of course, we can also analyze the device and give a full recognition of the device and what is, for example, the sockets of the rear panel of the device in order to connect such device. So just an example, we can see here a router. See we're analyzing the router. It doesn't run. Okay. Basically, the system is recognize the router. It recognizes the rear panel of the router, and it gives the customer the map of each one of this socket, what is the role of each one of the socket, and how to connect the cable to the socket. This is another example, which is the ultimate goal. So imagine that the customer called the agent or called the technical support center, and he basically get answer from a chatbot, not a human being, but a chatbot. And then he basically get, for example, a guidance of how to install a new router. I hope that it will run. Oh, it doesn't run. Oh, okay. So this is an example. So it takes the wrong cable, so it gives red X, which is the wrong one, and it gives instruction. Take, for example, the communication cable, and it gives the instruction to what socket to plug it. So, and then next stage is connect the DSL cable. So it gives instruction exactly to what socket to connect the DSL cable. And third stage is to connect the power cable. And to turn on the router or the modem. And the system now can analyze that all the connectors were connected properly, and if everything was done correctly, then it will recognize what LED should be blinked in what rate, and if the device is properly connected. This is the validation stage, and it is done also by the system. You see the blinking LED over there, and it gives you congratulations, you connected the Casada properly. So this is basically the method. And we are today pursuing in order to build all the building blocks that basically will fulfill this kind of idea. How much time do I have? 1 minute, okay. So technology drill down, I will go very fast. We are collecting a lot of images, as I said, by the video chat that we are having even today in Taxi Life. We are labeling all the devices. Namely, we are tagging and labeling all of them, so we are creating a database. In order to increase the database, this is another trick that we are doing, is that what we are doing is we are taking the database and we are augmented this database on different background. By this one, we are multiplying the amount of the database, the size of the database. Namely, if we have, let's say, one image, we can multiply it by 5 and train the network in order to increase the number of the device. And this is something that we are doing, and it shows that the probability of identification of the device is increasing quite dramatically. And we're also using what we called transfer learning. Namely, we are transfer learning is something that was first invented in the mid-90s. And namely, you can build new layers of the network, which is based on a similar devices or compatible devices that already the network have learned. For example, if you have a network of cars and you want to identify trucks, then you can identify trucks much better if you are building the layers on top of the network that was trained to recognize car. So these are the method that we are using in order to train the algorithm, and by this means we can have only a very small database in order to train the algorithms, and therefore we can manage to work with many devices, many routers, many washing machines, many television, and so on. Thank you. Sorry, repeat it. Yes. Yeah, of course, it's possible, but for this sense I have to show one slide. It's possible, but it will not give you the fidelity that we want to get. Namely, if I want to get a precision of 95% that this router is, for example, Casada 970, you will not be able to get it. We will be able to get it only if we train the network with a lot of modems, a lot of similar modems, and then to get it. You cannot find today a database that includes so many devices. I just want to show you one slide that basically show a comparison between our network compared with a well-known network such as Google and Amazon and IBM. When we show them this router and we try to analyze it, of course, we go to the 95%, and the other engine which has not trained as our network, they got these results.
Thank you, Professor Sarusi.